Hello, Physics Nation. My name is Nate Lermond, and I'd like to do a Khan Academy problem that asks for the magnitude of the acceleration of the skateboard along the ramp. So, we're going to apply Newton's second law. The net force equals the rate of change of momentum, or F equals ma. Whoops, pardon my sloppiness. However, the motion of the skateboarder is going to be parallel to the ramp. So we're really only interested in the net force that is parallel to the ramp. And that's the trick behind these problems. You're going to break your world up into perpendicular to the ramp and parallel to the ramp. And the trick is to take the weight, that is this vector right here, and break it up into those two directions. So let me draw a separate vector diagram over here. This guy represents the weight, mg. 1 kilo weighs 9.8 newtons. And here we go. Imagine a right triangle where a portion of this weight is into the hill or perpendicular to the hill, and another portion is parallel to the hill. Well, that's the portion we're interested in, this guy right here, because, like I said, the motion has to be parallel. And so if they want the acceleration, we want this force. What component of the weight is parallel to the slope? Well, we need to think about this angle right here. This guy is 60 degrees. All right, because we're forming a little right triangle, you just need to imagine the weight being one leg of the right triangle. Here's our 90-degree angle over here. So if this guy is 30, this guy has to be 60. They are complementary angles. And then if we draw our little vector diagram over here, you'll see, well, here's the perpendicular component of the weight. We're just taking this hypotenuse and breaking it up into two components, the perpendicular component and then the parallel component. And now this angle has got to be 30 degrees. So because this defines the perpendicular, and these two angles would be complements. So that's my short sort of, proof that this angle at the top of this little right triangle is the same as this angle down here. Anyway, maybe that's not a convincing argument. All I'm trying to say is this is the opposite side of a right triangle. And in order to find the opposite side, you just take the hypotenuse and multiply by sine of theta. And so this component right here is going to be mg sine of theta. Sine of 30 degrees is a very famous ratio. It's half. If this angle is 30 degrees up here, this opposite leg is half of the hypotenuse. And so we just come over into F equals ma and say, oh, well, the net force parallel to the slope is mg sine of theta, pardon my sloppiness, equals the mass of the skateboard multiplied by its acceleration, and mass is on the right-hand side of the equation, mass is on the left-hand side of the equation, and the acceleration just becomes g multiplied by sine of theta. And like I said, sine of 30 degrees is a half. That means the acceleration is going to be half of 9.8, or 4.9. There's the happy confetti. Thanks for watching. See you in the next video.